Hi everyone. Let's go ahead and work out this integral. So for something like this, when you have, let's say cosine or sine to an even power, then you want to think of using an identity. So this is the identity I'm going to be using. So recall that cosine square x, well, let's use x here, is equal to 1/2 1 plus cosine 2x. So this is derived from the double angle formula. So that's the identity I'm going to be using here. Now you see we have a fourth power. So you're going to split it up into cosine square and cosine square. So this can be rewritten as cosine square of x times cosine square of x, because by laws of exponent, that's cosine to the fourth power of x. Now I'm going to replace this identity right here and right here. So we're going to be expanding this out. Let's go ahead and do that. So this is equal to the integral of 1/2 1 plus cosine 2x times 1/2 1 plus cosine 2x dx. So I simply replace the identity. Now I'm going to go ahead and pull out the 1/2. So from here and here, I'm going to pull those out. So that will be 1/4 coming out. Then we have the integral. Now let's expand this out. So we know 1 times 1, that's going to give us 1. Plus, now here, if you expand this with that, and then this with that, you're going to get 2 of those. So you will have 2 cosine of 2x. And then cosine 2x times cosine 2x, that's going to give you cosine square of 2x dx. So I think I missed out an error right here. Okay. All right, so now that looks good. A little bit more confusing what I did there. Okay, so now you see that this term appears here again. So it looks like we're going to end up using this identity one more time. So we're going to replace that right here one more time. We'll have to make a slight change because that's the identity for cosine square x. So we're going to have to rewrite that because this is cosine square 2x. So for this one, we're going to be replacing with this identity. If you have cosine square of 2x, then that is actually 1/2 1 plus cosine of 2 times 2x. So be very careful with the argument. This will give us 1/2 times 1 plus cosine of 4x. So that's the identity I'm going to place in here instead of cosine square of 2x. So let's go ahead and replace that again. So this would give us 1/4 outside. So I haven't integrated. I'm just keep on rewriting until I know how to integrate each piece. So this is 1 plus 2 cosine of 2x. So all of these we know how to integrate. Plus, now the last term, we're going to replace it with that identity on the bottom. 1/2 times 1 plus cosine of 4x. And now we know how to integrate each of these pieces. All right, so took care of the identities. Now let's go ahead and expand this and integrate. So I'm going to go ahead and rewrite. So I have a 1/4 on top, outside. So if you integrate this one right here, respect to x, you're going to get x. Plus, now when you integrate this piece, you're going to get 2 times. So integral of cosine is sine. This is sine of 2x, but because of the 2x, we divide by 2. Plus, now when you integrate the second piece, this one, so here you can distribute this out, or you can do it mentally. So we know we're integrating 1/2 x, so that will be 1/2 x. Plus, now here we're integrating this and then times 1/2. So integral of cosine is sine of 4x, but of course we have to divide it by 2 and then times 1/2 from that term in the front. So this is completing the integration, of course, plus c. Now let's go ahead and distribute all the power, all the constant in the front. So if I distribute the 1/4 out, and I'm going to get 1/4 x plus, now here these will cancel out. So you're just going to get 1/4 sine of 2x. And then 1/4 times 1/2 x, that's 1/8x. Plus, now here, I'm gonna go ahead and combine this two, that's 8, and then times this 4 on the bottom. That's gonna be 32. So we have 1/32 sine of 4x plus c. Now, if you want to go ahead and take this to the next level, combine these. So those will give us, put them in common denominator. So I multiply the first one by 2/2. That'll give you 3/8x plus 1/4 sine of 2x plus 1/32 sine of 4x plus c. So that is one way to express the answer. If you want, you can pull out the constants and rewrite it, but I think this is good enough. So here we're able to use identity twice. So this identity right here on top, and then expand, and then we use the U substitution mentally to finish the integration.